So we've been talking in this class a lot about specifically what functions are and a lot of properties about functions, like what the graphs look like and how you can manipulate them and how it affects the graphs. What we're going to be talking about today is how you can deal with specific operations when dealing with multiple functions. And these operations are going to be the basic operations that you learned from uh, basic math, adding, subtracting, multiplying, and dividing. And we're going to deal with those from a functional standpoint when we're dealing with multiple functions. So what you're going to see is we're going to have some functions and we're going to perform operations with them. Now, when you look at this, the first thing that you learn when you learn about functions is what f of x means. And it just means y. And the first thing you probably are asking is what the purpose is for this new notation. And one of the reasons that we use this notation is for the very purpose of performing these types of operations. And it's going to be more convenient to have this notation for these things. So what we're going to do first is we're going to talk about what's called a sum of two functions. And that's the first basic operation that you learn. Now, when we talk about the sum of two operations, that means we're just going to add two things together. We have a function here defined, we have another one defined. So we are going to take the first function and add the second one to it. I'm going to add those two things together. So I'm going to add them together, but I'm going to put them in parentheses, and you're not going to see a direct reason yet, but in the next example you'll see why I put these in parentheses. But I want to emphasize that I'm taking this whole function and adding this whole function to it. So using properties of algebra, I'm going to combine like terms, combine the constants and the variable terms. So I have x squared that has nothing to combine with, plus 4x. The 1 and the negative 1 cancel each other out. So here is my new defined function. So that was the goal when it said define this. It means to define a new function for this problem. And it will say at times to evaluate when it's a different value. Okay? So when we talk about evaluating functions, we're talking about plugging in an x value. So I'm going to take this function and I'm going to evaluate this newly defined function at 3. So wherever I see an x, I'm going to replace that with a 3. So this is what I have here. So I'm left with 9 plus 12, which is equal to 21. Now you might ask, is there any way that I can check to see if this works? Well, our original function f of x was 2x plus 1. And if I plug 3 into that, you're going to get 7. My second equation was x squared plus 2x minus 1. And if you plug 3 into that, you get 9 plus 6 minus 1, that's 14. If you add those two things together, you get 21. So it works out. Now I'm going to talk about the second type of operation you deal with, and that's difference. So the same type of idea, but with subtraction instead of adding. So what we're asking to do is we're asking to define a new function. So I'm going to take the first function, f of x, and I'm going to subtract the second one. So that's equal to, and this is why it's going to be important to put it in parentheses. This whole function subtract the other whole function. So using properties of algebra, we have to combine like terms. we only have 1x squared, so that's going to be a negative because we're subtracting it. We have a 2x here and we're subtracting another 2x. Those cancel out. We have a negative 1 minus another, this is supposed to be plus 1. We have a plus 1 minus a negative 1. That's going to be plus 2. So here is my new function after subtracting them. So now the second part of the problem says to evaluate when x equals 2. Well, if we plug in x equals 2, we'll get a new x or a new y value for this function. So I'm going to plug in 2. Using properties of or orders of operations, I can't deal with the negative first. I got to take 2 and square it first and then add 2. So I'm going to get negative 4 plus 2, which is going to be negative 2. So my answer is negative 2. My function is written there. So my third operation is finding a product or multiplying. And again, the same idea. We have two things. We're asked to multiply them. So I'm going to take and multiply the two things together. So I'm going to take the first function and times it by the second one. So I'm going to take x squared and times it by x minus 3. And you get, using the distributive property, x cubed minus 3x squared. So there's my newly defined function for timesing these two functions together. Then it asks us to evaluate when x equals 4. Well, when x equals 4, I'm going to plug that in. So I get 4 cubed minus 3 times 4 squared. 4 cubed is 64 minus 3 times 16, that's 48. 64 minus 48 is 16. And again, you can plug those in and check in each individual function in this one and this one if you want to. This next one has to deal with quotients, and quotients are a little bit different. So when we talk about these, we have to be a little bit more delicate, because when we talk about quotients, we're going to run into a problem. You can't divide by 0. We didn't have any denominators in any of the other ones, so we didn't run into that problem, and so I didn't address it. So we are going to have to deal with that in this one. So it's asking us to divide two functions. So when you see this, it's asking us to take the first function and divide it by the second one, which is the square root of x divided by the square root of 4 minus x squared. Now you might think that you can cancel certain things out, but because the fact that they're both under the square root and they're not the same thing, we can't cancel anything out. So this is all we're left with for our function. So this is our defined function. This is all the further that we can go with this. So this is all we can write. We're not asked to evaluate, but this is my answer. So now I'm going to write the reciprocal of this. So I'm just going to write the exact inverse fraction of this problem. And again, you can't simplify any of this because they're two different radical expressions. So I'm left with this expression here. So now I have this problem about expressing domain. And we have two specific functions in here that you run into problems with when you define a domain. The first one is when you take the square root of something, it has to be non-negative. This has to be greater than or equal to 0. It has to be. You can't take the square root of something and get of a negative number and get a real answer back. So wherever we see a square root, we have to keep that in mind. Also, you can't divide by 0. So we have these two problems. We can't divide by 0, and we can't have a square root of a negative. So we have to deal with each one of these individually. So I'm going to deal with this one first, and we're going to talk about both of them and how they apply to this. Okay? So when I talk about this, what we talk about is the fact that we can't let this be have an expression be less than 0. So I'm looking at this thing under the square root sign, and I want to say this I want to be greater than or equal to 0. Okay? I want this to be greater than or equal to 0 because it can't be something else. So what do I do with this? Well, this is a factorable expression if I factor out a negative. Becomes this. If I factor out a negative, it becomes an easy factorable expression. Okay, so we have two test points at -2 and a +2. So if I pick -3, this is going to be negative, this is going to be negative, and we have a negative out here. So a negative, 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 this doesn't work. If I pick 0, I have positive, negative, negative. That all turns positive. That will be greater than or equal to 0. So this area is okay. This area is one that you'll find that doesn't work as well. So the region that this is okay is from -2 to 2. Okay, so that's the only region that that's okay for. Because when you pick -2, you get 0, and if you pick 2, you get a +0. Now for this one, we already know x can be greater than or equal to 0. So now we just have to plug this in to see what we can have. So the domain for this, well, we know x has to be greater than or equal to 0. For this one, we have where x can be between, but we have to think of another thing. If I let it be one of these two things, then the function is going to equal 0. Okay? If I plug -2 in right here, I'm going to get a denominator of 0. If I plug 2 in, I'm going to get a denominator of 0. So that's bad for this problem, so I do not want that. So this has to be between -2 and 2. I can't include those now because of the fact that if I include these two, I'm going to get a denominator of 0. So now I have two conflicting sets of inequalities. I have the numerator that has one, I have the denominator that has another. So I have to just say, where do they have the exact same thing? Well, it's everything here. If you graphed a number line, it would be all of this stuff. So from 0 to 2, or from -2 to +2, and from 0, or excuse me, it's not all of that. What I'm going to do is, in the next video, I'm going to finish talking about this problem, and I'm going to tell you how to finish finding the domain of this.